In this video, let's practice identifying whether each of these given numbers is prime, composite, or neither. Remember, to be a prime number, the number has to have exactly two factors, one in itself. To be a composite number, the number has to have at least two factors, but not an infinite number of them. And last but not least, there are two numbers that are neither prime nor composite, and that's 0 and 1. The reason why the number 1 can't be prime or composite is because it only has one factor, and the reason why 0 can't be prime or composite is because it has infinite factors. For each of these examples, I'm going to prove whether these are prime or composite or neither. For number 1, we have the number 12. Now, we know that 1 times 12 is 12, that's a given, but if you can think of anything else that multiplies to get 12, like 3 times 4, then it's not going to be prime anymore. We know that for number 1, this one is going to be composite. For number 2, we have the number 9. Well, let's see. We know 1 times 9 is 9, so that's a given. But we also know that 3 times 3 hopefully is 9. If that's true, then we know that this is composite. So if you can list any other pair of factors or another factor that multiplies to get it, then it's no longer prime. For number 3, let's see. We know we have 1 times 10. That's a given, and then we have 2 times 5. So because we were able to identify another pair or another set of factors, this is a composite number. For number 4, we have the number 11. So let's see. We have 1 times 11, that is 11. And can we think of anything else that multiplies to get to 11? And if you can't, then we know that this is a prime number. So 1 times 11 is it. There's nothing else that makes it prime. For number 5, we have the number 2. Let's say we have 1 times 2 equals 2. But I think that's it. So if that's it, you can't think of anything else. And there's nothing else out there, then it is prime. All right. For number 6, we have the number 15. So we, of course, have 1 times 15. I'm trying to think. I know, 3 times 5 is 15. So we were able to come up with another one. And so that is going to be a composite number as well. For number 7, we have the number 18. So that's definitely an even number. So any even numbers besides 2 will always have the ability to be a composite number, or always will be a composite number, just because you can divide it by 2. So 18 is a composite number. All right. For number 8, we have the number 13. So of course we have 1 times 13. I'm trying to think if anything else goes into 13. I can't think of anything else. I think it's the only thing we have here, which makes 13 a prime number. It has exactly 2 factors. For number 9, we have the number 7. So of course we have 1 times 7 as a pair of factors, but I think that's going to be it. So 7 is indeed a prime number. For number 10, we have the number 19. So of course 1 times 19 is 19. And you have to ask yourself if there's anything else out there. I'll tell you right now though that there is not. So you should definitely think about it. But if you absolutely can't think of anything and you've tried everything, then it's probably going to be prime like it is here. For number 11, we have the number 20, so 1 times 20, of course, but we also know hopefully 4 times 5 is 20, so again, I'm only listing one more than the bare minimum, so we know it's composite. If you wanted to think of other factors like 2 times 10, that's also okay. For number 12, we have the number 21, so 1 times 21, and what else do we have? Oh, I think 3 times 7 is 21, so that makes 21 composite. For number 13, let's see, we have the number 28 here. So for 28, of course, it's an even number, so it's going to be composite. I think 4 times 7 is 28, right? So 28 is composite. For number 14, we have the number 25. So we have 1 times 25. But remember, we also have 5 times 5. So 5 times 5 is 25. So we just confirmed that this is a composite number. For number 15, we have the number 24, so 1 times 24. And then I know 3 times 8 is 24, so that proves this is composite. You could also say 2 times 12 or 4 times 6, and that would have helped as well. For number 16, we have the number 27, so we have 1 times 27. But we also have 3 times 9, right? 3 times 9 is 27, so that makes 27 a composite number. Alright, so these are pretty quick. Once you get the hang of knowing what things are divisible by and you try them out, you have to kind of go through your multiplication facts or practice doing some division as well. For number 17, we have the number 35. So of course we have 1 times 35, but Because it ends in a 5, hopefully you know that 5 times 7 is 35, so we've proven that this is a composite number. For number 18, we have the number 38, so we have 1 and 38. It can't be prime because it's even, and it's not the number 2, so 2 times 19 is 38, and so this is also composite. For number 19, we have the number 40, so we have 1 times 40, right? We also have something like 4 times 10, you could say like 5 times 8 or 2 times 20, but this is definitely a composite number. For number 20, we have 56, so we have 1 times 56. And let's see, I think I know 7 times 8 is 56, right? So I just proved that this is composite. You can also prove this with maybe 2 times 28 or 4 times 14. Those are all possibilities as well. For 21, we have the number 39 here, right? So for the number 39, we have 1 and 39. But we can also say we have 3 times 13. I knew it's divisible by 3 because if you add the digits, 3 plus 9 is 12. And so if the sum of the digits is divisible by 3, then the whole number is divisible by 3. For number 22, we have the number 31. So we have 1 times 31. And you can try thinking about other possibilities, but I'll tell you right now that it is prime. There are no other factors for 31. For 23, we have 1 times 37 equals 37, and that's going to be it. There are no other factors of 37 that are whole numbers. For 24, what do we have? 41, we know is 1 times 41, but it turns out that is it, and there is nothing else out there. 41 is a prime number. All right, let's check out 25. For 25, we have the number 45, so of course we have 1 and 45. It ends in 5, so it's divisible by 5. So 5 times 9 is 45. That makes 45 composite. You could have also used 3 times 15. That would have been fine as well. For number 26, we have the number 49. So 49, we have 1 by 49. But we also have 7 times 7. So hopefully that fact comes to mind, and that makes 49 a composite number. Again, it has more than 2 factors, but not an infinite number. For 27, we have the number 51, so we have 1 times 51. And a lot of people think this number is prime, but again, if you remember the divisibility rule for 3, if you add 5 plus 1, it's 6. So that is divisible by 3, so it turns out 3 times 17 is 51. So that makes this 51 a composite number. Be careful with that one. For number 28, we have the number 53, so we have 1 times 53. But it turns out that's going to be it. There are no other factors for 53. You can try them, but there are no other whole number factors. For 29, let's see, we have the number 57. So 57, we can definitely say 1 times 57. And can't divide by 2, but how about 3? 5 plus 7 is 12. 12 is a multiple of 3, so it turns out 3 times 19 is 57, which makes 57 a composite number. For number 30, we have the number 59, so we know we have 1 and 59, and it turns out that's it, so 59 is a prime number. For number 31, we have 1 times 87, but is there anything else? Well, it's not divisible by 2, but how about 3? 8 plus 7 is 15. 15 is a multiple of 3, so it turns out 3 times, I think, 29 gets you 87, so 87 is going to be a composite number. Last but not least, we have this number 32, so we have 83. So we do have 1 times 83. But I can't think of anything else that gets you 83, so 83 must be a prime number if we go ahead and check those, but that's it. So none of the numbers on this worksheet were neither prime nor composite, and the only numbers that are neither prime nor composite are 0 and 1, so just look out for those in the future. Hopefully this helped you feel a little bit more confident with identifying which numbers are prime or composite, but it's really just going through and checking what numbers are divisible by others. You can use a calculator or practice long division or go through your multiplication facts, but you just have to try those out to see. And once you get used to it, you'll be able to identify which numbers are prime or composite a little bit easier. So again, hopefully you found this video helpful. Thanks for stopping by, and as always, keep up the great work, and I'll see you in the next one.